Hello students, today we are going to discuss about ADC interfacing with 8051 microcontroller. Okay, so ADC stands for analog to digital converter. So this ADC is interfacing with 8051 microcontroller. Okay, so first we will discuss about what is meant by ADC. So ADC is nothing but as analog to digital converter. So it will convert the analog value into digital value. So the analog value must be in the form of voltages or current, and the digital values are called as zeros and ones. So that digital values are called as the binary values. So here we are going to use the ADC converter. Okay, the ADC converter is called as 8-bit successive approximation analog to digital converter. So this IC ADC 0804 is manufactured from National Semiconductors, and the ADC 0804 having some features. So the features are it having differential analog voltage input and the voltage range in terms of 0 to 5 volt, and it have no zero adjustment, and it will having built-in clock generator, and it will contain the reference voltage. So that reference voltage can be externally adjusted to convert smaller voltage span into 8-bit resolution. So the IC called as ADC 0804, which will convert the analog value into digital value. So let us see the pin diagram. So the pin diagram which contains 20 pins. The first pin is CS chip selection, the second pin is read, and third pin is write. And read and writing are the basically active low signal, and fourth pin is clock input, and fifth pin is interrupt pin, and sixth pin is positive voltage, seventh pin is negative input voltage, and eighth pin analog ground, that is A, G and D, and ninth pin is reference voltage, and 10th pin is D, G and D, that is nothing but as digital ground, and 11th to 17th pin or data bus pin, that is 18th pin DB0 to DB7, data bus 0 to data bus 7th pin. That is what the first pin is the LSB, least significant bit, and the last DB7 is the MSB, that is most significant bit, and 19th pin is clock pin, and 20th is positive VCC, that is nothing but as power supply. So now we are going to discuss about what are the steps for converting the analog input into digital output by using ADC 0804. Okay, so it having some algorithm. Okay, so it having some 5 steps. So that 5 steps will explain the converting procedure of analog into digital value. So first the step is make sure CS equal to 0. That is what, make chip selection equal to 0. So after making CS equal to 0, we'll send a low to high pulse to right pin to start the conversion. Okay, so if you send a low to high pulse to the right pin, that pulse will decide the start the conversion. So next step is now we have to checking the interrupt pin. Okay, the interrupt pin having two conditions. When the interrupt pin will be 1, the conversion is not finished. Suppose if the interrupt pin is 0, the conversion is finished. Okay, so please note down, it's a very important point. If the interrupt pin will be 1, the conversion is not finished. If the interrupt pin is 0 means the conversion will be finished. Okay, so 0 is what? 0 is low, and 1 is called as high. Okay, so see the third point. So if conversion is not finished, that is what, interrupt equal to 1, high, pole until it is finished. Okay, we have to keep on checking the interrupt pin. So we want the interrupt pin is equal to 0. If it is 0, the conversion will be finished, and then we'll move to the next step. Okay, so see the next point. If the conversion is finished, the interrupt equal to 0, we can move to the next step. So the final step is again we can make CS equal to 0 and send a high to low pulse. So this time we can send a high to low pulse to the read signal. So that pulse will decide the data. That is what, the microprocessor will read the data from the ADC, that is analog to digital converter. So these are the steps for converting the digital output. Okay, so repeating. So the first pin we can make CS equal to 0, and we can send low to high pulse to the read pin. Okay, the same as the last step is we can send a high to low pulse to the read pin. So that pin shows the microprocessor will read the data, will read the digital data from the ADC. So these are the different steps to converting the analog input into reading the output from analog to digital converter. So yes, this is the diagram and this is the block diagram. So this block diagram shows how the ADC is interfaced with the 8051 microcontroller. Okay, so I will explain you guys. So see, the first block is nothing but as ADC block, analog to digital converter, and see the second block is 8051 microcontroller. Okay, so see in the ADC converter, right? So the circuit initiates the ADC to convert a given analog input, then accepts the corresponding digital data, and it displays on the LED array connected at P0. Okay, so the first block is what? ADC, and second block is 8051 microcontroller. See, the 8051 microcontroller, it having some ports, right? The port 0 pins which are going to connecting with the LED. The LED shows the final digital output. Okay, so see, for example, if the analog input voltage Vin is 5 volt, okay, if the given input was 5 volt, if the given input is 5 volt, then the all LEDs will glow indicating 1 1 1 1 etc. So up to what? 8 1. See, if the input is 5 volt means all the port 0 pins, all the values, binary values are given as 1. So the LEDs will start to glow. Suppose if the input is 0 volt means all the values must be a 0 if the LED is not glowing. So this is some sample output of ADC, and here we can using the 8051 microcontroller. So the data out pins, that is what? D0 to D7. So see the diagram. So D0 to D, see the ADC diagram. The D0 to D7 of the ADC are connected to the port pins P10 to P17. So the data output pins which are connecting through the 8051 microcontroller by using port 10 to port 17 pins, and here the LEDs, right? So in the right hand side, the LED side, the LEDs D1 to D8. So see the diode. So that LED is showing some diodes, and in the top of the diode there is here two arrow mark is there, right? So these are called as what? Diodes. The LEDs D1 to D8 are connected to the port pins P0 to P0.7. Okay, so these LEDs are connected from the microcontroller by using the port 0 pins. Okay, and here resistors, right? So in the resistor R1, R2, R3, R4, R5, R6, R7, R8, right? So these 8 resistors are called as the current limiting resistors. So, and see the 8051 microcontroller, in simple words, the port 1 of the microcontroller is the input port and port 0 is the output port. Okay, so port 1 is the what? Port 1 is the input port and port 0 is the output port, and the control signals, okay, the control signals are called as this chip selection, CS, read pin, write pin and interrupt pin. So these control signals are connected through port 3 pins. That is what? Port 3 7th pin is connected to the CS, and port 3 6th pin is connected to the read, and port 3 5th pin is which is connected to the write, and port 3.4 is what? Interrupt pin. Okay, so these 4 are called as control signals. Okay, so here at first we can send the low to high pulse to the right pin, so that signal will send the start of conversion, and after that the interrupt pin is keep on checking. If the interrupt pin is 1, the conversion is not finished. Okay, if the interrupt pin is 0, the conversion is finished. Okay, this is the third step. Okay, and the final step is again we can send a high to low pulse to a read pin, so that signal will show the microcontroller will read the data from the ADC. So these are the 4 steps to converting the analog input into digital output. And next in the diagram, resistor R9 and capacitor C1. So yes, in the left hand side the resistor R9, okay, the value of R9 is what? 10 kilo ohms, and C1 are associated with the internal clock circuitry of the ADC, and here the R10 is the preset resistor. Actually the preset resistor R10 forms a voltage divider which can be used to apply a particular input analog voltage to the ADC. okay, and push button S1, resistor R11 and capacitor C4. It forms a debouncing reset mechanism. And finally the crystal, right? The crystal, here we are using the quartz crystal. The crystal X1 and capacitors C2, C3 are associated with the clock circuitry of the microcontroller. Okay, the crystal which generates the clock frequency, that will show in the diagram. In the top of the diagram there is a clock circuitry. Okay, so this is the block diagram of ADC converter interfaced with 8051 microcontroller. The simple mechanism what, at first the ADC will convert the digital value, right? That digital value will be sent to the 8051 microcontroller, and again the 8051 microcontroller will send the digital value to the LED. So this is the basic operation of ADC interfacing with the 8051 microcontroller. Now we are going to see the program. This program for how it converting the analog input into digital output. So the first code shows move P1 comma 111 111 and 111. Okay, so this first instruction which shows the port 1 as the input port. We can move the value 1 to the P1. So this first instruction which shows it will initiates the P1 as the input port. Okay, and first again clear. So CLR stands for clear P3.7. okay, so here we can make sure CS equal to 0, because what, just see the block diagram. The block diagram, port 3.7 pin which is connected to the chip selection. So what is the algorithm? First step, we have to ensure we have to make CS equal to 0 and send low to high pulse to right pin. So that's why we are putting here clear P3.7. So clear is nothing but as 0. We can clear the previous value. Clear is 0 and set equal to 1, right? So don't forget guys, clear is 0 and set is 1. Okay, 0 is low and high is 1, right? And see the second instruction, third instruction, set B. So set B is nothing but a set bit P3.6. So we can set, that is what we can make read high. And again we can clear the port 3.5. So port 3.5 is what, right pin. We can clear the value. So here makes right equal to low, and again set bit port 3.5. so this instruction which shows we can send a low to high pulse to right for starting conversion. Okay, so according to this instruction we can start the conversion process. And see the next instruction, wait, that is what, JB jump back port 3.4 comma wait. So this is nothing but as the interrupt signal, right? So port 3.4 which is connected to the interrupt. So what is the condition actually? So if the interrupt is 1, the conversion is not finished. Okay, if the interrupt is 0, the conversion is finished, right? So 0 is low and 1 is high. So we can ensure interrupt equal to 0. If interrupt equal to 0, the conversion is already finished. And again the instruction clear port 3.7, that is what, again we can ensure CS equal to 0 and clear port 3.6. so that is what, we have to send a high to low pulse to read for reading the output data. So this is the, so up to this instruction these are the conversion mechanism. And next, what is the procedure? We have to move the digital values to the LED screen, right? So again move A comma P1. So we can move the digital data to the accumulator register, and CPL space A, that is what, we can complement the digital data, and move P0 comma A, that is what, the accumulator, the value which can be stored in the accumulator, we can move into the port 0 pins, because the output pins are called as port 0. Finally we can jump back to the main program, and again it will start the conversion. So this is the program for converting the analog to digital signal, and then finally we can move the digital values into the LED screen. Okay, so that's all about the ADC interfacing with 8051 microcontroller. Here we are using ADC 0804. So that is the ADC IC. Thank you.